Given that for the existence of every force there is another force, could there be a better way to describe things than forces? The answer to that is yes. In modern physics, the models for forces look a little bit different. One perspective is that they are more focused on interactions. In other words, there are like interaction terms. That's literally what goes into the theory, is a description of interactions rather than forces. Another perspective one could take is that the form that those interactions take can actually be the exchange, or be modeled as the exchange of force carrying particles. And when you have force carrying particles being exchanged, Newton's third law kind of makes kind of natural sense from that perspective. So you might say, like, well, why wasn't this obvious in Newton's time? And I think part of the answer to that is that the full evolution of the scientific method and the experimental basis of it just wasn't there yet. But I've often felt there was maybe this clue there. But like I said, sometimes, one could argue that when I say there's this clue, you could say, well, how come they weren't smart enough to see that then? And that's sometimes when you look at history, hindsight can be 20/20. And, looking at it from a modern perspective, it's easy to be guilty of that in science. Many textbooks are actually, many experts even are guilty of kind of reformulating the history of science based on a modern perspective that then kind of is not really correct to the way people thought actually at the time that something was discovered. And that may be true here. Let's check out the answer, though. It says here, in modern particle physics, what might be described by forces in classical physics are instead described by interaction terms in a Lagrangian density. And that's specifically the kind of thing that comes up in like the standard model of particle physics or in particle theory. It's not the only thing that's out there, you could say, because like you can say, well, is everything like that? And there's maybe newer theories that are coming around the corner, perhaps, that may look different even. But I don't know. I think this will still be there. Anyway, more broadly, forces are describing the effects of interactions between two things, and nature seems to function based on this. In classical physics, this is expressed in Newton's third law. In other words, we have to have Newton's third law. I would never expect to see an experimentally verifiable exception to Newton's third law.